go ahead and get started. So thank you so much, everyone, for coming. Really happy to welcome you to the launch of the third edition of the book, Life Course Approach to the Epidemiology of Chronic Disease and Aging. So my editors don't need any introduction in Life Course Epidemiology, but for those of you who don't know me, my name is Blodgett. I'm a senior research fellow and I'm based at the Institute of Sport, Exercise and Health at UCL. I actually did my PhD at UCL. Guy Ku was one of my supervisors, and Yoav is actually my upgrade examiner. So today is actually a really nice full circle moment. For me, the previous editions of the book were so instrumental in my training, in my research, and in my career to date. So it's been a real privilege to join the team as one of the co-editors and get to work alongside so many incredible contributors from around the world. So I want to start by thanking George for hosting the book launch, and thanking Julia for all of her hard work behind the scenes and making this happen. We've got a really great program of speakers today. Unfortunately, one of our speakers had to drop out because of travel, but we have Guy Ku, who's going to start us off with an introduction to the third edition, highlighting some of the changes since the previous one. Then we've got three contributors, two joining virtually, and then Yoav and Ezra are going to talk to us about what we've learned. So some key reflections from this edition and looking ahead to the future. A couple of housekeeping things. So for those who are joining online, if you have any questions at any point, feel free to put it in the chat. It won't show up on the screen during. We'll be able to take questions after each chat as well. We'll take them first from the room before going to the online ones. It is being recorded, but again, for people joining online, only the panel of speakers will be recorded. So your videos or your audio won't be. And then at the end of the session, for those who are in person, we've got some drinks and some nibbles, so I invite everyone to stay and to join us. So without further ado, I'm really happy to introduce Professor Guy Ku, who will give an introduction to the third edition.
I've had to bring notes because I've just done an imperial cognitive test, and although I'm excellent on planning, my memory is failing me. So I will, and it's lovely to see both new faces and familiar faces, both online and in person. I'm going to briefly introduce how this third edition came about and its broad aims. And the graph here shows the popularity, how the popularity of the term life course has really increased since the 1990s, used by many different disciplines and also by international agencies and national policymakers, although I agree that the conceptual frameworks are not always entirely consistent. I thought one of the most intriguing examples that I found was when it was even applied, they applied our life course models to a hyena project in Kenya because they had 30 years of data on 4,000 hyenas. So that's one of the more unusual ones. I recognize four distinct phases of life course epidemiology. In 1997, when the first edition of this book came out, we were young and near the beginning of our careers. The book represented a revival of pre-war ideas on the childhood origins of adult health, and its review of the evidence linking risk factors from early life onwards to adult chronic disease was a synthesis of three etiological models of chronic disease at that time: fetal origins, social deprivation, adult lifestyle. Its success led to an OUP series of life course books. The second edition followed on quite quickly. You can see all the editions here. Hopefully you can read them. As the evidence base grew, the conceptual models, the frameworks, models, and methods were developed. Young contributors turned into professors and brought a new generation of young researchers to co-author their updates to their chapters. The gaze of life course epidemiology also widened to include new research, like, for example, the women's health books, which is now also in its, it's in its second edition, which I did with Rebecca Hardy and then also with Peter Mishra. And then a third phase started about 2008 as life course epidemiologists grew increasingly interested in functional trajectories as a way of assessing lifelong health and found common interests with colleagues in aging research. And one output here was the Healthy Aging book in 2014. The slide also illustrates the other books in the series, and one including by Ezra, co-edited by Ezra on mental disorders. I've called phase 4, starting about 2019, the value of life course epidemiology in an age of pandemics and other global challenges, and I'm going to explain why. From 2017 to 19, when asked to bring a life course perspective to an EU report on aging, I became much more aware of life course research that was already ongoing on things like zoonotic diseases, pollution, antimicrobial resistance, and climate change, and how that could be affecting later life health. Then the COVID pandemic came along, and we got involved in publications bringing a life course perspective to COVID-19. Despite this increasing interest, in July 2022, when OUP got in touch to see if we were interested in doing a third edition, it seemed like much too much work. I kicked it into the long grass, and Yoav said, definitely no. The new OUP editor was persistent, and she asked again. So I wrote to all the people who'd been on the previous books. They were all still alive, I was glad to see, and the commentaries and the editorials that they'd written. And I was amazed how the positive response I got, particularly from Ezra and some of the other, Mike Hansen from the DOHAD group. I think he might be on the line as well. And that made me think, okay, maybe we can do it. And I had sent out saying I'd like to do it by looking at a life course perspective in the age of pandemics, climate change, and other global challenges. And I wanted to bring together the development, or the group who were more focused on the developmental origins of adult health and disease, DOHAD, with the life course books. So in the end, we ended up with 55 contributors, many more than in our first edition, from all across the world. So the aims of the third edition are to review the value of a life course approach to health in the age of pandemics, climate change, and also widening social inequalities. This went right across all the chapters. To assess the recent evidence linking early life factors or earlier life risk factors to chronic disease and aging, and with an increasing focus on lower and middle income countries. To show how this evidence is being or could be informed by new technologies, methods, and collaborative science, and to discuss how to use evidence to improve population health in low middle income countries as well as high income countries. So we requested some common themes to go across the chapter. We circulated this figure, which we adapted from the EU work I did, to illustrate what a common theme was to consider the interplay of the individual lifetime risk factors with the macro social and macro physical environment, where there were many increasingly big challenges. And so that means considering the long-term or latent health effects of single or cumulative exposures, whether these effects vary by age or cohort, and whether earlier life factors modify or exacerbate the effects of pandemics or climate change on population health and vice versa. That's in a nutshell, but obviously there was much more than that. The other kind of common themes, and again, most of these do come up in most of the chapters, was to try and look at the growth of life course research in lower and middle income countries, the improved exposure measurements and high resolution data in the life course epidemiological models, how that was improving our models, new developments in study design methods and statistical analysis, and a lot of the chapters talk about Mendelian randomization, which I know you all know about in Bristol, and all of those things featured. And also, we wanted to have many more chapters on how you translate the life course research into policies and interventions, and the need to integrate the life course infectious and climate epidemiology and DOHAD developmental biology and geroscience. So before I very briefly, I'm almost at the end, show you the sections. You know, you won't be able to read, some of you at the front may be able to read some of these words. But I saw on Saturday in the New York Times that it was reported that the US government agencies have recently flagged a remarkable number of words that should be limited or avoided, for example, on their websites or in their reports or documents. Our book, I am very proud to say, contains many, not all of these words. But I think Ezra is going to talk about this when he speaks. It is really incredible. Even socioeconomic is on this list. I mean, okay, so then my last just couple of points is really to tell you that the book, that you won't have seen actually the whole edition, that it's divided into three sections. Section 1 looks at the opportunities and challenges for life course epidemiology in the 2020s. Tonight, I hope you're going to hear from Mary Johnson. Is she? Oh, good. Who co-authored the climate change chapter with a whole team of them at Harvard, and Oliver Robinson, who's in person, who co-authored the exposomics chapter. And then in section 2, we updated the evidence from life course research into specific chronic diseases, but also added multimorbidity and biological aging, where Luigi Ferrucci actually asked to put in that chapter, which was very nice, and unfortunately cannot speak tonight. So Kerry Keyes kindly agreed to show how this approach is being used for mental health and well-being, and she's already online to do this. And also, can I say, James Allison is here, who wrote chapter 9 on the respiratory function, and would be delighted to network with people who are interested in that topic. And then in section 3, we expanded the number of chapters to focus on the implementation of life course approach in policy and interventions. These chapters cover lower middle income countries and high income countries, and they look at 4 different life stages: intrauterine period, infancy and childhood, adolescence and young adulthood, and middle to late adulthood. And Yoav will talk a little bit more about that later. And then in the conclusion, we have a shortish conclusions in the book, looking at the challenges, priorities, and future directions of life course epidemiology. Yoav and Ezra will try and complete the talks today by highlighting the key points that emerged and the lessons that we learned across the chapters that our contributors kindly wrote. I want to end with a big thank you to all those colleagues and to my co-editors and to George Davey Smith, who wrote the foreword, lovely foreword to the 3rd edition, and also agreed to host this launch. And thank you for listening. We're on time, so, but I don't need, if you have questions, we can do that at the end, I think. I think you want to hear the others.
So Mary, you can go ahead and share any slides you have. So I'd like to introduce Dr. Mary Johnson, who's a principal research scientist from the Department of Environmental Health, based at the Harvard School of Public Health. She's going to be talking about her and her team's chapter on a life course approach to the health consequences of climate change. Whenever you're ready, Mary.
Okay. Is that showing correctly on your screen? Okay, great. Well, thank you for having me. My name is Mary Johnson. I'm a research scientist here at the Harvard School of Public Health in the Department of Environmental Health. And we have, for years, been looking at the health impacts really of climate change, which incorporates obviously many aspects of some of the consequences of climate change on our health. Just as a little background, we're an immunology lab, so we look at primarily how different environmental exposures, often in the context of climate change, impacts our immune health, which encompasses things like allergies, asthma, and many chronic diseases have an inflammatory component. So I'm going to go through just some of the ways in which climate change, through various methods, there'll be a heavier focus on air pollution and wildfire components, but how those impact the lifespan from birth to the elderly, and hopefully, shed some light on how the age of the person really defines how susceptible they are to some of these climate change variables. So as we all know, the increase in the greenhouse gases has resulted in some increased global warming, but also these, as a result, these extreme weather patterns, whether it's things like increases in wildfires, in hurricanes, in droughts, flooding, and there are, I could talk for probably 3 days in the ways in which different types of extreme weather patterns impact our health. So I'm going to go through just some studies that kind of highlight what we've learned and about the relationship of our health to climate change. So this is just kind of a good summary slide of the different ways in which climate change, both directly and indirectly, impact our health. And also, it's kind of nice in the green. You can see how some of the social, the SES, the socioeconomic status, and the different variables also interplay into how a person's health is impacted by the various components of climate change. So just to give you an overall view, when we talk about, one impact of climate change, the increase in air pollution, often research looks at PM 2.5, which is particulate matter that's 2.5 microns or smaller, that is increasing. And we know without a doubt that the more PM 2.5 that you're exposed to, the shorter your lifespan will be. So there's increases in not only morbidity, but mortality with increased exposure. And this is a global phenomenon. And even though this particular graph is, from 2018, we can see that some countries actually have their lifespan decreased by over 2 years simply because of the air quality. In United States in 2018, we were on average in the United States, our health span was decreased by about 4 months simply from air quality. And so one place to start is how our DNA, how our epigenetics is impacted by factors of climate change. A lot of the research revolves around air pollution and now wildfire smoke exposure. But what we know, if you look at this figure where you see the red, it means that that stage in life has an increased susceptibility to particulate matter exposure. And, we know that, and I'll show you some studies in a moment, that pregnancy in particular is a very critical time, early childhood, and then the elderly. And as we go through, I'll try to highlight why these different age ranges are more susceptible to the impacts of climate change. So when we talk about pregnancy, we know that exposure to not only air pollution, but wildfire smoke will increase the rates of preterm birth and low birth weight. Part of that depends on what trimester the mother is in. Part of it depends on the intensity of the smoke, whether it's, kind of a low exposure or very high exposure, and how much exposure they're experiencing. And in addition, unfortunately, stillbirths are associated with air pollution exposure. And for the mother, gestational hypertension, which, also puts the baby at more risk for adverse health outcomes. And respiratory problems in the newborn, I will talk about in a moment. For pregnancy and also other life courses, what we know is that exposure to things like air pollution, wildfire smoke induces inflammation in the body, oxidative stress, and then epigenetic changes, which means that our DNA is not mutated, but it's up or down regulated based on exposures. Typically, it's not, it's a detriment to our health. So I wanted to start with this particular study because I think it's a good example of how climate change is can impact a person from in utero to adulthood. In Australia in 2019, 2020, they had mega wildfires. And during this time, they looked at adults who had been born premature. And what they found is those adults who were premature babies had more difficulties with their respiratory system during the smoke exposure in 2019, 2020. And overall, they had more problems with obstructive airflow. And this, isn't too surprising, given that we know that when babies are born prematurely, they typically have lung dysfunction and it can last throughout adulthood. But, this is a very good example of how exposures in utero can and will have long-term health impacts. As we look at children and in relation to climate change, we know that most children less than 5 globally experience poor air quality. So they do not live in an area where the air quality falls within the WHO guidelines. And where you see the darker blue, that is where the air quality is the worst. And the cobalt blue color shows that almost all children under the age of 5 are exposed to too much air pollution. As we move into the teenage years, this is a study that actually came out of our lab, and we looked at teenagers that were exposed to a forest fire that was over 60 miles away. And we compared their immune function and looked at the markers in their blood compared to teenagers that were not exposed to wildfire smoke. And interestingly, what we found is that there were increases in inflammatory markers in their blood, so subclinical impacts from exposure to the wildfire smoke, even though we didn't see overt clinical impacts. And the reason we think this is so interesting is because we really don't know if this lays the foundation for adult onset chronic health problems. Whether or not the increases in these inflammatory markers, IL-1 beta and C-reactive protein, result in, for example, increased risk for high blood pressure as an adult, or obesity, or other types of respiratory and cardiovascular outcomes. Mental health is something that's associated with climate change. Typically, when they're talking about mental health impacts, the research is looking at the impacts of heat, and we know that unfortunately, the increase in temperature is associated with increased rates of suicide, up to 37% times higher with only 1 degree Celsius of warming. We know that another way it may have impacts are on medications. When they're exposed to heat, they may be less effective. We also know that work performance decreases when the temperature is increased. One interesting study looked at just pediatric emergency room visits and the relationship to kids coming in for psych-related reasons, and whether or not it was associated with increases in air pollution. And it was, with just a 10 micron per cubic meter increase in the PM 2.5, there were increases in kids coming in, adolescents, for psych-related reasons, which is quite frightening. We also know that there's other types of mental health impacts, such as increased anxiety in older adults when they're exposed even short term to increases in PM 2.5. We mentioned the suicide completion and attempts increases. And, we are learning more and more that there are associations with various types of mental health impacts as well as the physical health. Older adults, there are many ways in which the impacts of climate change are associated with their health. This is just one example. This was from the JAMA, the Journal of the American Medical Association, showing that older adults, when they're exposed to increases in ozone, have increased mortality. And this is quite unfortunate, and there's various reasons that this could occur. Older adults are more likely to have respiratory and cardiovascular chronic disease. They also have reduced ability to deal with the heat in terms of their ability to sweat as effectively. And so, ozone is just one correlation with mortality, but there are many others. And so, as we mentioned, the ability to adapt to climate change is there are definitely populations that have a decreased ability to do so. Obviously, children have a decreased ability to do so. I believe I have a slide on migration. With climate change and the increase in migration, children are much more susceptible. The other thing that we covered in the chapter are some of the respiratory, allergy, and other specific health outcomes from climate change. So if I have enough time, I'll go through a few of those associations. So asthma and allergies.
Sorry, Mary, I think if you could just wrap up in the next minute or two, that would be great.
Okay. So I'll just say that with climate change, we have increases in asthma and allergy associations, respiratory effects, particularly wildfire. There are associations with changes in the vectors, which these different types of viruses are transmitted and where it increased susceptibility. Cardiovascular effects are associated with climate change, and even treatment for people with cancer. There are impacts associated with climate change in this particular study. The hurricanes caused increased decreased survival with the lung cancer patients. So we could go on and on. COVID also associated with climate change. And this is just a summary slide showing the many ways that across the lifespan, we've got changes, detrimental impacts on our health from the climate change. So thank you. Sorry if I went too long.
Thank you, Mary. Just in the interest of time, we're not going to be able to take any questions. Mary, will you be sticking around if there's any questions at the end? Can't see.
Yes.
Yes, that was a nod. Fantastic. Thank you. So our next speaker is here in person. Dr. Oliver Robinson is a lecturer at the MRC Centre for Environment and Health at Imperial College London, and he'll be talking about his chapter on exposomics.
Great. Got my stopwatch.
Great.
Thanks, Joe. So I'll talk about the exposome. Here's a nice globe of how correlated the exposome is in Spanish children. I wasn't quite sure what to include, so I tried to do a whistle-stop tour of the chapter, and so I have a lot of slides, but I'll try not to overwhelm you. How do I do this?
The right arrow.
Yeah.
This one?
Yeah. No. Yeah. Oh, once it's stopped. Do you want to? That worked for me. Yeah.
Great. Okay, so actually almost 20 years ago now, Chris Wilde, a cancer. Hello? There you go.
Oh, yeah.
Okay.
That's the best we can do, I think. You don't want to take it off. Yeah, if that's okay, that's fine.
Oh gosh. I'm not gonna do that. Sorry. I use Teams.
Yeah, but you don't know that's
Everyone
the-
is Teams.
Could we show the screen through Zoom on
There it
here?
is, there it is.
Yeah.
Fine.
Okay,
Okay.
that's the best we can do.
Yeah.
Hopefully I haven't got much in the top corner. No, yeah. We all right?
Yeah, could be somewhere else. Yeah.
Okay. So this was Chris Wilde, former head of IARC, cancer epidemiologist. This was really a call to arms saying, come and look, all this money's been put into the genome at that time, and we have very good coverage of the genome, and we have great precision, all this funding. So we really should do the same for the environmental side of disease etiology. And so this was his definition that I think we all stick to. Exposome is all environmental exposures, including all those from diet, lifestyle, endogenous sources as well, from conception onwards. So explicitly a life course approach.
It's not getting, it's a problem.
That's it.
Okay, so I'll click on that.
Right, you can do it.
You sure? Okay. Okay. Right. So what is the exposome? So just this is his original conception. I don't know if you've seen this, but really he said the exposome is specific external factors, and this is a traditional realm of environmental epidemiologists and risk factor epidemiologies, but also this general external domain, which is more the causes of the causes, and perhaps the realm of social epidemiologists or social scientists, but it means actually people like me have been getting more into this. And what's the key part of the exposome is recognizing that the internal environment is a source of exposures. So one fruitful avenue has been looking at how maybe social factors, how it gets under the skin and can influence disease risk. And he said aging was a key internal exposure. So this has really been in parallel with this geroscience paradigm, and it's very interesting as a sort of a cumulative record of exposure. So this is a life course picture. This was back in how Wilde said we should do it. And some of the first studies, like Helix, have been looking at the first two arrows, and currently they're looking at the third red arrow. But of course, the exposome just makes it more complicated. So we're now looking at many factors at once, or we'd like to. And why it matters, I mean, an estimate is perhaps we know 51% of the current environmental contribution to chronic disease. I mean, we can argue with how they calculated this. So there is still a substantial unknown environmental contribution. And if we look at the production by chemical industry, we can see in the past 20 years, the amount of stuff that's pumped out into the atmosphere, into the environment, has doubled. And it's still going up. So we know there is all this stuff in the environment, but perhaps only 20% has been studied. And so it's widespread, it occurs in mixtures, and it can have low doses, but together it may have some substantial effects. So this is an example of screening the water exposome. So looking at all the different compounds that were detected in our water samples, and you can actually classify rivers based on all the contaminants in rivers. So can we do this for people? Can we stop looking one at a time and look at all these different exposures? So this is an example in Helix, where they had this concept of the urban exposome. So this is an approach which we can layer different geospatial assessment based on where people live, of their green space, their noise, the built environment. So with all these factors, we can do this at quite a large scale and look at what, using a sort of genetic GWAS approach and an exposome-wide approach, you can see the green space, this is NDVI, as the green space measure increases birth weight or is associated with an increase in birth weight. You see some of these air pollution factors have the opposite effect. And in a subset, they could then supplement this with by monitoring questionnaires, mobile devices to get a broad range of exposures amongst these children in pregnancy and childhood. So we measured about 100 exposures, and here you can see some interesting exposures that you might expect, such as on lung function, crowding, how dense the place they live, and some of these pollutants. These are parabens and some phthalates that occur in plastic bottles. So it's quite a strong effect there. But then also Rappaport said, is one of the key figures, actually we should be able to do top-down exposomics. So can we actually take a drop of blood like we can for a genome sample and then agnostically assess the environment? So one way we can hope to do this is all these post-genomic omics. So omics is a key part of the exposome, including the metabolome, measurement of small chemicals, where we can directly measure pollutants in blood, and also the epigenome DNA methylation, which is interesting because it may help us look at longer-term imprint exposure. So these are all the things that we can measure in blood with current high-resolution mass spectrometry. We're getting down to these very, like dioxins, we might need more specialized mass spectrometers, but actually now we can measure thousands of compounds in a single sample. We only really know hundreds of them at the moment, but this is something that we hope to keep improving. So this is an area that's really important. But of course, we know it's not that simple with exposures. So this is looking at different exposures for a hypothetical child who is breastfed and his mother is a smoker. And you can see for some of these persistent pollutants, there's this cumulative increase during breastfeeding. But some of the non-persistent pollutants, it's just a continuous change of exposure. So actually, one time point is not really going to help. So this is one of the problems here with this idea of genome exposome analogy. But here, this is an interesting example of why we're excited by DNA methylation. So this is the strength of association of different CpG probes in DNA methylation with smoking. And you can see there are some that are very persistent. And this red is the p-value, the strength of association, and some decline gradually since quitting. So we can build up a picture of lifetime or life course exposure to smoking. And so this idea being extended for DNA surrogates. And this has been shown with proteins, for instance, with something, here's an example for CRP, that we can have quite a rapid temporal increase in CRP levels. But actually, if we're interested in sort of more chronic levels, then actually we can use DNA methylation to make a surrogate, like, for instance, Horvath's epigenetic clock, which you may have heard of. It's the surrogate of age. We can do this for exposures. So this can be very useful for different environmental exposures because we might be able to average out the varying levels. So one example that we've been looking at is lead. So lead is very hard to measure. You need special X-ray spectroscopy. But one study has DNA methylation and this specialist measurement. And this is in the test set. You can see quite a good correlation of 0.6 between measured and surrogate predicted level. So what this means is I can take this surrogate now and apply it in my cohorts that I have access to, such as the HELIX study and the airwave study in adults. And as you expect, you do see this consistent association with a reduction in working memory in adults and in Helix just in the boys, actually, which is actually one of the main effects of neurotoxicity. So this is quite promising. I think I've nearly done it in time. And so another way that maybe we can look at long-term exposure, I think this is a really exciting example. This is from mouse cell work, but you expose them to different exposures and there's a distinct mutation pattern. So there's a pattern of changes in the DNA structure that is distinct to benzopyrene, the main carcinogen in tobacco smoke, or ultraviolet light, or aristotic acid, which is a plant toxin. So what's exciting here is actually, if you look at biopsies from lung cancer tissue, you can see there's a distinct mutation signatures, these C to A conversions. And this is the same signature of benzopyrene. So here we have a record of exposure that's also connected to the mechanism of disease, so somatic mutation load. So this is what we hope to achieve, I think, with exposomics. And you can see that this has now all been catalogued. You can go to the website, so different mutation signatures associated with different exposures. So lastly, this is the exposomic study, which is another one of these early studies we were involved in. And here they've tried to do this life course approach by bringing together lots of studies over the life course and doing similar approaches. And one of the main approaches of this is the meet in the middle approach, where can you take mechanistic data from omics, connect this to the exposure, and also does this predict outcome, in this case, cardiovascular disease? And we did see for inflammatory proteins and also for inflammatory pathways with DNA methylation data and exposure with both the exposure and the subsequent risk of disease. So this is an idea that how we can sort of increase causal inference by bringing in mechanistic data in these observational studies. And just to show, this is a very latest study in UK Biobank, and these biobanks are really what we need if we want to measure all these exposures. And they've done this for all the different exposures and also linked to proteomic aging as well, which, as I mentioned, is a sort of record of environmental exposure in its way. So just to sum up, and I know I've rushed through this, but I think I'm still on time. The exposome is a very broad concept. I'd say it's almost the danger of being so broad it becomes meaningless, but really I think it is sort of modern chronic disease epidemiology. And really the aim was to provide an environmental analogue of the genome. And of course, as it's time varying and the effects of the exposome are time varying, the life course perspective is crucial. And so what is exposome research? Well, it's high dimensional research, or it's the incorporation of this sort of high dimensional omics data. But there's still lots of challenges, so we're still catching up with the concept, much like I think life course epidemiology caught up with the concept as well over time. Yes, so I think this integration of mechanistic data really enhances this evidentiary pluralism. And ultimately, with AI, we should be able to enhance disease risk prediction scores. So thank you, and thank Paolo, Vanessa, and Giovanni for my co-authors.
I think if anyone has any burning questions, we can take one. Otherwise, Oliver will be around at the end.
I think we should go on because rather than be around, won't you? Yeah. Then nobody will, anyone, nobody online, so that's, oh, no interest.
Perfect. So Kerry, you can go ahead and share your slides when you're ready. So our next speaker is Professor Kerry Keyes, who's a professor of epidemiology at the Mailman School of Public Health at Columbia University. She'll be talking about her chapter on mental health and well-being.
Thanks so much. And I think you're seeing the right slide, right?
Yeah.
Great. Well, thank you for inviting me to talk about this chapter and for inviting me to contribute to this important volume. This book has been an important part of my scholarly trajectory, so it was a real honor to be asked to participate. And with my colleague Gonzalo Martinez-Alez at the Department of Psychiatry at Mount Sinai, we wrote a chapter on a life course approach to mental health and well-being. And so I'll describe a little bit of our approach, and I wanted to highlight some key classical studies that we cite in the book as a way to promote discussion. And because this is a general audience, I'll start by talking about our definition of mental health. What does it mean to have mental health and well-being? These are kind of general concepts, and we generally define mental well-being as a state that enables individuals to cope with stress, to realize their abilities, to learn and work, and to contribute to their communities. And within that, mental health includes thoughts, feelings, and behaviors that structure our interactions with others, that align with our senses of safety and security, and that anchor our understanding of self and purpose in society. So that's a general definition of what it means to have mental health or mental well-being. And then the other side of that is mental health distress and disruptions in well-being. Now, mental health distress and disruptions are universally experienced. We all have distress and disruptions throughout the life course. These range. They are very dynamic. You can have distress and disruption throughout days, throughout a day, throughout weeks. And then we refer to kind of prolonged and serious distress and disruption under the category of psychiatric disorders, and these are often endured across years. So in medicine, what we typically do is we create clinical categories based on symptoms that we deem as pathological, and we denote these categories as psychiatric disorders. There are many different categories of psychiatric disorders, and I'll highlight a few of the main ones, many of which we review in this chapter. Common psychiatric disorders include those that affect mood and affect, such as depression and anxiety disorders. Behavioral disorders typically constitute addiction and substance use disorders, conduct problems and antisocial behavior, and then thought disorders that include a range of different disorders in the schizophrenia and psychosis spectrum. Other disorder categories have in the past often, but not always, been included in categorizations of mental health. These include neurodevelopmental disorders, some forms of schizophrenia, as well as disorders such as autism spectrum disorders, but sometimes they're moved into other categories of medicine as well. So in summary, how we try to approach this chapter is that mental health is a broad set of underlying dimensions within which we create some categories and we designate those as pathological disorders that rise to the level of needing intervention and in many cases, treatment. So within that, we started to think about, well, what is a life course framework for studying mental health? We know that psychiatric disorders and mental health symptoms unfold across the life course, that there are risk factors that have been identified in the literature that are both cross-generational and within person, beginning at conception and leading into older age. Like many of the conditions that are in this volume, risk factors are multi-leveled. Society and social positioning shape a sense of self and purpose and can lead to these feelings of distress and prolonged symptoms. And so with that, a life course perspective really needs to enhance our understanding of causation and action in mental health and well-being by forcing us as researchers and decision makers to make explicit the theoretical models that we're using to define these concepts of mental distress and psychiatric disorders, as well as what point in the life course they place their interest. So in the chapter, we provided a kind of overall framework for how to think about multi-level and life course risk factors. A similar type of figure could probably be produced for most of the outcomes that are covered in this chapter. But essentially that risk factors for mental health and well-being across the life course really range from individual level factors, from the social factors that we experience, genetic risk, behavioral risk, and then fanning out from there to multi-level and community risk factors, neighborhood and municipality level, and regional and country level factors as well. So with that framework, I'm just going to provide three examples of classic papers that we have used in psychiatric epidemiology and in the epidemiology of mental health to advance life course thinking, or that is really kind of formalized, I would say, the life course thinking that we do in this discipline. We covered, we framed in the chapter that like you could apply this kind of life course multi-level framework really to any mental health or psychiatric outcome. And that we couldn't in one chapter or even one entire volume cover every single psychiatric disorder and every single potential risk factor. And so we chose a few examples of how life course thinking has been applied in this discipline. We covered prenatal determinants, early life experiences and adverse childhood events, and then life course causation of late life mental health and cognition. So I'll just provide one example of a classic paper that we highlighted in the chapter for each of those three areas. So for prenatal determinants, I think one of the most classic papers, and I'm so glad Dr. Susser, my longtime mentor and friend, is here today because he can answer anyone's questions about this study. But I just wanted to highlight this study as really such a foundational paper and how we think about life course causation as it pertains to psychiatric disorders. And this is Dr. Susser and colleagues' paper on prenatal malnutrition and schizophrenia. And I should also say in all of these examples, the three examples that I'm going to give to you, they're all examples of using natural experiments, which have been really influential in the life course field for psychiatric disorders to overcome issues of confounding and other biases that can arise in observational designs. And so Dr. Susser and colleagues used the natural experiment of the famine in occupied Holland towards the end of World War II that lasted from 1944 to 1945. It intensified over time and then ended very abruptly in May of 1945. And the most severe famine was during a 2-month period during that time. So in this paper, what Dr. Susser and colleagues did was link records of the likely dates of conception based on birth records to adult outcomes of schizophrenia and other outcomes as well, including at birth CNS anomalies. And what they were able to demonstrate in this paper is that those adults who were conceived during the height of the famine, during the 2-month height of the famine, when they were most exposed to prenatal malnutrition, during that very early part of gestation, just in the first trimester, that those individuals had an increased risk of all three outcomes in adulthood. This is after age 24 for the mental health outcomes, schizophrenia and schizoid personality disorder, and that those risks were heightened compared to other individuals who were exposed to the famine and even the height of the famine during gestation, but not in that early developmental period. This led to a number of new areas of research for the field and really cemented the role of the in utero environment and the early childhood experience as influential for adult psychiatric disorder risk. So then moving to the second area that we cover in the chapter on early childhood experiences and adversity in early life, I wanted to highlight, a paper that many people, or a series of papers that many people are probably familiar with, from the Great Smoky Mountain study. This was a longitudinal cohort that began during age 9 to 13 among children living in rural areas in the Great Smoky Mountains area. And again, taking advantage of a natural experiment. And this is the fact that a casino opened right in the middle of data collection. And this casino afforded increased income, family income, to American Indian families in the study. And they were able to demonstrate that in the study participants, shown here on the left is the non-American Indian families who really experienced no substantial change to their family incomes. This is the percentage of families that fell below the poverty line, but that among the American Indian families, that throughout the course of the study, the proportion of American Indian families living below the poverty line substantially declined due to this increased income from the casino. They then divided the participants in the sample into those that were persistently poor, persistently below the federal poverty line throughout the entire study, those that rose out of poverty due to the opening of the casino, as well as those that were never poor throughout the study. And I'll just highlight here, and this is a paper published in JAMA in the Journal of the American Medical Association. Across many of the psychiatric outcomes they studied, consistently they found that the ex-poor, the families that of Native American children who rose out of poverty due to the opening of the casino, experienced declines in total psychiatric symptoms over a 4-year period. So this goes from childhood to adolescence, especially in late adolescence. There were declines in total psychiatric symptoms, in behavioral psychiatric symptoms, in emotional problems, and in mean annual frequency scores of total symptoms. So all of those declined, particularly in this group of the ex-poor, and did not decline in the group that were persistently poor and never poor. And just to highlight more, if you compare across the 3 categories of persistently poor, ex-poor, and never poor, those children that were in the ex-poor group, the children who rose out of poverty, by adolescence, their symptoms of psychiatric disorders were similar to the children who were never poor throughout that time period. And this provides, evidence that these interventions to improve poverty and to provide people with a stable living wage are a psychiatric intervention. And just to highlight that they also followed up these families into adulthood. And so among those children who were exposed to the casino opening as children, especially those who were in the youngest cohort exposed to the casino opening, once they were adults, so now they're 21 years of age and around that time, they experience prolonged benefits of having been exposed to the increased family income due to the casino, especially around substance use disorders. There was particularly a concentrated effect of becoming ex-poor due to the casino on alcohol and cannabis abuse, dependence, and both. So finally, I'll just end, we also covered late life psychiatric disorders as well as mental well-being. And I wanted to highlight one study that we cited in the paper that used instrumental variable analysis, or a natural experiment, to examine the effects of early education on late life memory and cognition. And so what these investigators did, and we cite a number of different meta-analyses that incorporate this paper, but I just wanted to highlight this one. These investigators took advantage of changes in state laws in the United States around compulsory schooling, the age that children have to begin attending school, and compulsory schooling work laws, the age that you can quit school in order to begin work. So they used a cohort of older adults, people who started to be followed in their 50s and 60s and beyond, and linked those cohorts to the compulsory schooling records of their states in the 1940s, when a lot of these compulsory school laws changed, and used that change in the compulsory school law as an instrument to examine the effects of education, of years of schooling, on older age memory and cognitive outcomes. And the goal here is to overcome the effects of confounding that you might anticipate between years of schooling and older age memory and cognitive outcomes through things like childhood IQ, personality, socioeconomic status, and other factors. And what they found was that when you do a variable analysis, you observe consistent effects on older age memory based on 1 year of additional schooling due to the compulsory school law. So across all the different models they studied, including unadjusted, adjusted for birth year and sex, state of birth indicator variables, and state characteristics, there were significant and quite strong effects of 1 additional year of schooling on memory outcomes in older age. They did not observe the same effects for mental status or cognitive ability. The effects were particularly concentrated in memory outcomes. Now, as I mentioned, this is a whole body of literature at this point, all of which has differential associations. There are quite mixed associations for compulsory school laws overall. But I highlight this paper because it really catalyzed that entire field of the literature, and I think is exemplary of how we can use some of these novel designs in order to cement our thinking about how even, older age memory and cognitive ability are linked across the life course to these early life experiences. And I'll just end, kind of summarizing some of our conclusions. And the question that we asked in our conclusion, I think is relevant for all of the chapters in this book and for all of our work, is how can societies support a population to promote mental health and well-being? And we posit that given that there's well-documented risk for psychiatric disorders and other mental health outcomes that really occur across the life course, from malnutrition in utero through compulsory schooling and income in childhood and adolescence, these accumulate across life transitions. And so too can we point to intervention and prevention efforts in those early stages that would promote a society that improves mental health and well-being through alleviation of childhood poverty, access to resources for supporting and caring, rearing for adults in children's lives, high quality early education, supportive connections for displaced populations, which is another area that we get into in the chapter that I didn't have time to today. And that, I think I included this because particularly at this fraught moment politically, I think it's important to point out that political classes and political ideology may disagree about the best routes to intervention, but no matter where we disagree politically, it remains clear that a careful eye tuned to how the youngest among us are developing supports a society that prioritizes health and wellness for all. So with that, I will end and would love to take any questions or comments.
Thank you, Kerry. I think, again, for the interest of time, we'll skip the questions, but if you can stick around at the end and have any, that would be great. So Yoav is now going to be joined virtually by Professor Ezra Sisser, and they're going to be sharing some of the key sections from the final chapter, reflecting on the book as a whole and on the future, what is to come.
Thank you, Joe. So I think I've learned is never agree to try and summarize 20 chapters in 130,000 words in 15 minutes. So it's a ridiculous task, but we will try. Myself and Ezra will try. And it's a bit like what Oliver said, there's a danger trying to be so covering everything to end up being rather superficial and bland, but I hope we'll have some provocative thoughts. So in the concluding chapters, as Guy showed earlier, these were the main headings or subheadings, which we're just going to briefly talk about. I'm going to talk about the first 4 bullet points, and Ezra will end on the last 2 bullet points. So to start with, and I just, as it came out last week in the Lancet, I thought I would just remind people of this. This is the latest GBD publication. This is predicting trends in childhood obesity and overweight. This is just that this is the age 5 to 14. What's really interesting, back in 1990, unsurprising to any of us, high-income countries were at the top of the obesity league table. If you believe these predictions and you go forward to 2050, we're still not doing great, but we've now been overtaken by Latin America, Caribbean, and interestingly, North Africa and the Middle East. And what's really worrying, of course, it's going up globally. What's less clear, and they do discuss this a little bit, is what are the drivers of these regional variations. And of course, I'm sure it won't be too long before they submit another paper looking at the simulated predictions on cardiovascular disease and stroke from these disease trends. But what is actually true, the wonderful decline, at least in high-income countries that we saw for cardiovascular disease and stroke from the 1950s onwards, have absolutely stalled. And the whole idea of healthy life expectancy continuing to improve and overall life expectancy is not getting better and better as one might have hoped. So there are major public health issues going on in terms of future health prediction. And one of the chapters written by Claudia Bornhurst and colleagues from the Bremen Institute discusses novel methods of analysis of life course data. Again, can't go into any great detail, but very much as Oliver said in his talk, one of the things you really need is good big data sets, varied data sets, good measurements. And the people here can't see, but in the top right-hand corner, I just put the logo for UK LLC, which a lot of you will be familiar with, which is the UK linkage study set up during COVID, but now expanded to look at all health outcomes. And these collaborations and making data sets accessible are really key. But what's interesting, and I'm a natural born skeptic, so I still remain skeptical. We're all very familiar with causal modeling. In their chapter, they talk about machine learning, AI, neural networks for what they call causal discovery. So we haven't heard, again, Oliver mentioned AI in passing. I mean, one of the big changes is the whole technology and methods for looking at data and picking up patterns or picking hidden messages within data. So this is a fairly early example. So you might look at it and say, oh, that's a DAG, a directed acyclic graph. And of course, if you look carefully, it isn't, because there's some bidirectional arrows here between BMI. This is eating behaviors in young people. And again, some unresolved. This is all bottom up. This is giving data to a machine and asking it to determine the DAG, okay? Which is slightly dodgy in our minds, or my mind. They rightly say that they think the best approach would be a top-down, informed, and a bottom-up approach. But the whole idea is, with enough data and complexity of data, there may be patterns in the data that we may not have predicted or seen, which a machine learning or neural network approach might identify. As I said, I remain skeptical. It's very early days. The technology is going to improve. Hopefully, we will see future examples where this really is an interesting way of looking at data. Okay, so one of the big questions, and the questions when I talk to people about my research and life course, they all say, well, okay, so what does it tell us about intervention? And as Di pointed out in the third edition, we have a lot more about interventions and looking at the different life stages. So the first thing I think it's really important to say is that life course epidemiology or DOHAD and other things, that it's not deterministic. There is absolute evidence that intervention at all stages of life have benefits. And as a public health person, I tend to think about it in terms of primary, secondary, tertiary prevention. So even when you have established disease, if you have a disease-modifying therapy, or you can just slow down the rate of progression, that is still valuable. However, it doesn't mean they're all equally cost-effective. And so I guess the question is, how do we know? Should we put more money into preventing child obesity or focusing on adolescents or young adults or middle-age obesity? And of course, the problem is you don't have direct randomized controlled trial evidence, because who's going to wait for the RCT of children for 30, 40 years to see what the outcome is? And hence you are forced to use either simulations or use intermediary outcomes and then predict on the basis of that what would be the benefits. And there's still, in many areas, there's still lots of unknowns. However, I would say most of the chapter contributors do highlight child and adolescents as being particularly sensitive periods for intervention, so potentially far more effective. And of course, there's lots of good reasons for that in terms of health behaviors, cognitive development, growth development, bone mass, and so on, and how those predict future trajectories. And then in the later life, we have several chapters saying that, particularly in this day of multimorbidity, rather than focusing just on diseases like diabetes or cardiovascular disease, we really need to look at things like intrinsic capacity and slow down rate of functional decline. It's a shame that Dan Belsky couldn't come and speak today, because I'm sure he would have raised that issue. So one chapter I just wanted to highlight, because I think it's a really excellent chapter, was by Natalie Slotman and Jack Shenkoff, where they reviewed social policies or different policies and the evidence. And again, we can argue about the quality of the studies, then methodologically. Like Kerry said, a lot of them, some of them are natural experiments, some of them are randomized trials. There's obviously issues of follow-up, particularly for long-term, but they raise some really interesting points. So a lot of them focus on childhood, again, on the argument that this is a particular sensitive period for development, and that you might get more bang per buck. Interestingly, so one example in their chapter is the Moving to Opportunity study. It's an American study where poor people were given housing vouchers, which they could use to either relocate or improve their own housing. And interestingly, in that study, they found very interesting gender differences. So another point they make is these interventions can have heterogeneous effects. In terms of what people do, they are sometimes based on families, sometimes based on schools, preschool educational interventions, and sometimes just based on communities, so neighborhoods or areas, often focusing on housing and employment. And again, it's important to highlight that these studies are not all positive. They can have negative and positive effects. Key thing that they raise, which I think is really important, is what they call theory of change, to have better causal models of what the intervention is going to do both in the long term, but in the short term. And as I said, for many of these things, you have to use natural experiments because there are no randomized trials. And I've just shown this slide. This is referred to in their chapter. It's a really lovely example. People will be familiar. This is the board in Bradford. This is the trials within cohort design. So John Wright set up this big multi-ethnic cohort, but within that, they use this as a platform to test feasibility for randomized trials. And as you can see here, these are a variety of different interventions, some as maternal, child behavior, breastfeeding duration. What's wonderful, by doing it within a cohort study, you can look at your responders, non-responders, you can look at the generalizability of your sample. So in terms of early intervention, which seems very positive, what are the reasons to support that? And some of them are pretty obvious. So for example, we're all familiar with smoking in pack years. The sooner you can stop people smoking, you're going to reduce the exposure to a nasty carcinogen. But some of them may just be more amenable to intervention. Interestingly, we don't know really the answer to this. If you're going to try to encourage physical activity, are interventions more effective in young adults or in children, adolescents than later life? But we do know these behaviors track. So if you can establish more positive physical activity, that will track to later years. If your causal model relies on interaction between an early exposure and a later one, then obviously if you can remove the early exposure, you will avoid the interaction. So the classic example, which has been studied a lot, has been the interaction between low birth weight and adult adiposity on cardiovascular disease. And then obviously, and I'll show another example for this, if early exposure already starts to initiate irreversible damage, then obviously the longer you're exposed to, the more likely you will have bad outcomes. However, early exposures have negative aspects, things like stigmatization, labeling. People may be less motivated to take part. And one of the interesting things in the chapters, there is a certain tension between those authors who come very much from a social epidemiological perspective, who believe intervention should be social structural, versus those with a more biomedical approach, looking at greater mechanistic insights, and we are gaining greater medical insights, and obviously potential danger of over-medicalization. So just an example I really like, this is from the cardio and MESA studies in the US. If you look at the left graph, the white circles, this is blood pressure, these are all people who've been treated on antihypertensives, these are all people who've never been treated, and at 25-year follow-up, they have almost identical blood pressures. But as you can see, those who are treated have got a greater area under the curve. So they've been exposed over their life course to more hypertension. And these are the results of what happens to them. So surprise, surprise, given the same blood pressure at follow-up, those with more exposure have over doubling the risk of heart disease, CVD, heart failure, and stroke. And that fits very nicely one of the models we've proposed, whereby if an exposure tracks later on, if you only intervene at time point C, that's great, you will reduce risk, but you haven't removed the adverse effects of A and B acting on the outcome. So here's an example where clearly early exposure has some longer term benefits versus later. And then the one area I just wanted to raise, so there is a lot of research on life course influences on disease incidence and risk. There's relatively little research in terms of an area I think is really interesting in what determines recovery from insult. So here's a paper looking at stroke recovery, arguing that your cognitive reserve, which is clearly established early in your life course, will improve your recovery over and above the severity of the stroke in terms of imaging, neuroimaging, and so on. And people have argued that that may also be true for other things like recovery after heart attack and so on. So clearly there's an area of understanding life course determinants of recovery, which I think is still very much in its early phase. I'm now going to hand over to Ezra. Tell me when you want me to go on to the next slide.
Okay, thanks, Yoav. And thanks to everyone, to the co-editors. And, you know, I met Daiku, I think it was just about the time the book came out, the first book, and it really influenced me enormously. So it says here I'll discuss these 3 points in 5 minutes, but I learned this morning that I have 10 minutes. So it's probably going to be something in between. So first I'm talk about the expanding life course research in low and middle income countries, then the COVID-19 pandemic and life course implications, and then the new political era in the USA, which isn't in the book because it began after we finished the book, but is now, I think, of overriding importance. Could you go to the next slide? Yeah. So expanding life course studies in LMICs. We already heard from Yoav, and you probably already know that there's been a great increase in non-communicable diseases in low and middle income countries, which creates what they call double burden, because there's still infectious diseases are still very common, and as are other kinds of illnesses. But this is like a major change that's happened for most of the world's population. But the timing of this increase varies between countries a lot, and also within countries. And so, for example, in the chapter 19, which focuses the most on this, to give an example of a South African study of increasing overweight among adolescents, and they compare a rural and an urban area. And they found that this began earlier, this increase in overweight in the urban than the rural area. But they also found that once it started, it occurred much more rapidly in the rural than the urban area. So, you know, the course of the increase in the end in overweight was different in urban and rural areas in South Africa. And we actually don't know which of these will have more impacts on the life course health, or whether they'll be the same. There really are a whole number of reasons for doing life course studies in LMICs, which are, of course, 85% about the world's population. They reveal variations across the globe and clues to the causes and have implications for intervention. And I won't say more about that, but I think that's a major point. Can you go to the next slide? So there are several LMICs that have launched really excellent life course studies. And I'm going to use an example from Brazil, but it's one of many. But we have to keep in mind, too, that these are exceptions. Even though there are quite a few, there are a large number of countries that don't even yet have vital statistics like, you know, birth and death. And, you know, so it's by no means universal. And we have to build capacity much more across the world. But let's take the example from Brazil, which I think is a very good one, mentioned in the chapter. They call it the 100 million Brazilian cohort, which has been followed over time. And so it's big, 100 million. And what they did is they created a single registry for an array of social protection programs. And that includes, I think the largest was the Bolsa Familia program, which was, I'll tell you about it in a minute. But it investigates, the purpose of the cohort is to investigate the impacts of policy on social determinants of life course health. So, you know, that it relates to what Kerry and was saying about, you know, natural experiments and, you know, the impact, what many people are saying about the impact of policy on social determinants. And thinking about extreme poverty, which is one of the examples, the Bolsa Familia program was a conditional cash transfer program, but it was combined with other programs for low-income people, and it was done in the context of a universal health service, which they have in Brazil. And on the right, you can just see that it more than halved the proportion of people living in extreme poverty in Brazil. So there are many others, but I think that's a really exciting one. Can you go to the next slide? So now I want to say a few words about the COVID-19 pandemic and health over the life course. You already heard from Mary Johnson that you know, the pandemics are part of a whole interrelated set of global changes that are occurring. We just covered pandemics here, and you there's a historical context of pandemics. Several massive transformations in civilization, like the decline of the Mongol Empire, the transition from the Middle Ages to the Renaissance, were precipitated by global pandemics that wiped out, a third of the global population. And there's other examples too. So it's not a new thing, but it's certainly a dangerous thing. And we focused on a number of points, and these are some of them. That there was a great variation by country and by region in the public health response to COVID-19. And one of the surprises, at least was a surprise, but a surprise not just to me, I think, was that one of the countries with the worst responses and the highest death rate was the United States, although it had been rated as the most prepared for a pandemic. And some low-income countries actually did much better than the US, using just basic public health measures like contact tracing, so forth. Another intriguing, I don't know what to call it, points about this pandemic had to do with vaccines. Because on the one hand, you had probably the most rapid vaccine development that we've ever seen. But then you had glaring inequalities or inequities, really, in global distribution of the vaccine, because the wealthy countries that produced them, that produced the best, the ones with the best evidence, the mRNA vaccines, for example, did not share them with other countries, which was a step back from HIV/AIDS, where they were forced to share them. So that was, I don't know, I would call it unconscionable, but it happened in order to protect the patents, which generate profits. It's also true that while we had this incredibly rapid vaccine development, due to this amazing biomedical advances, US is turning away from that now. As you probably know, we have the person in charge of all this no longer really is a vaccine advocate, and vaccine studies are no longer favored in the US. So I don't know what will happen next time. Then we also discussed the variation by age, by age, which you all know about, by sex and gender, by socioeconomic position, ethno-racial factors. I think those are well known, those differences, some we could call inequities, and but also pre-pandemic health. That was a major factor in terms of your vulnerability to die, for example, from COVID. And there are kind of two different processes in operation here. One is differential exposure. So people who had jobs that couldn't stay at home, that had to go out and work with the general public, that's an example of differential exposure, but also effect modification, because pre-pandemic health, also varies by all those factors listed above. So these processes, differential exposure and effect modification, both occur and sometimes synergistically. So, we conclude that we really have to follow this up, because we know that COVID has it affects virtually all body systems and does so over time. And so we need longitudinal studies with sufficient follow-up to look at the independent, cumulative, and synergistic effects on later life health, really in all domains. And that includes, though it isn't limited to long COVID, which affects, the widely varying estimates of long COVID. But, whatever estimate you take, you find at least 5% of a population that was, exposed to COVID will go on to have disabling, very disabling long COVID. And last point is that if the long-term consequences differ by age, then obviously the initial period effects will later be observed as a cohort effect, because some people will be exposed in sensitive windows. And there are different sensitive windows for different things, child development, early socialization, adolescence. I won't go on. I think you understand that point. Next slide, please. So now I'm going to talk about the implications of the new political era, which was, I don't know how to say it. I was expecting something bad, but I wasn't expecting I was expecting much worse than most people expected. But it's even worse than I expected by a long shot. So what's happening, So with relation to the kind of things that we're talking about here, I think we all agree that global collaboration, data sharing are essential for future progress. They're two of the pillars, So let's take the example of pandemics, So how do we do with global collaboration and data sharing with COVID-19? We were partially successful. There was the problem of vaccine distribution, all kinds of problems. But there was some success, and some countries shared data readily, and there were global collaborations set up and so forth. So it's really urgent to advance and solidify these collaborations to be able to deal with pandemics in the future. But unfortunately, instead of moving forward, we're moving backwards now, because things don't only happen in the USA, but it's such a large part of global health programs that has a massive influence. So since we finished the book, global health programs funded by the US have essentially been stopped. So we have no more the means that we were using to detect pathogens that might become pandemic have been halted. We don't have surveillance anymore. We don't have, well, there's so many things, but also public health research is specifically under attack, and epidemiology in particular, because these are met with hostility by the movement that Trump heads, if you like. And the CDC has been extremely weakened and is not allowed to communicate with the WHO. So I can't imagine, we already don't have, good national data in the United States. That's one of our great weaknesses, no universal healthcare and so forth. But if you're not allowed even to talk to people in the WHO, I don't know how we would deal with a pandemic, which becomes much more likely under the new scenario. So I think that the future of life course research depends a lot on resisting these changes and building a different future. It might be difficult to, if you're in another country, it's kind of hard sometimes to internalize the kind of changes and the rapidity with which they're happening in the US. But, just for example, 2 days ago, all my major grants were canceled without notice. But, school, this Columbia University was hit the hardest because they're considered a symbol of resistance. But it's the attack is on all universities, and in particular on global health and public health. So I just think that we have to have, our integrity and our principles to resist this, or we're going to go backwards. And I got one more, I think. Yeah, if you could just move it on to, yeah. Okay, so the last word. This is from our chapter, and basically, I think these are the principles we have to stick to and stand up for, that as a public health community, we need to consider how best to support populations at every developmental stage, to process these experiences, to be able to live lives of dignity and purpose. And such endeavors require scientific collaboration and advocacy, especially for those who are most marginalized. This is actually, for all intents and purposes, illegal to do in the United States now, but we're going to do it anyway, for as long as we can. And I hope that other countries will fill in some of the gaps. Okay, thanks.
Yeah, we're sorry, everyone, we're running a bit over. So I'm just going to hand over to George for some closing remarks. But one final thank you to George for hosting us and for everything that Julie has done today.
I won't say anything.
Oh, yes, you will.
That's okay. Okay, I've got 2 PowerPoint. Sure. Because I was told that
Oh, come on, we want to hear you, George.
So I came in and I found out I had 10 minutes rather than 5 minutes. And being an epidemiologist, I can just about make 5 minutes without a PowerPoint. But the idea of 10 minutes, so I'm not going to do 10 minutes. I'll just show 2 PowerPoints and I'll make one. I'll show 2 PowerPoints.
Can we just ask, do people have questions for the virtual people who are staying on? Because if they do, we can ask them, you can come up and ask them afterwards. But I just wondered if that's going to be something that people will want to do. Just don't be shy. I mean,
So I was just going to reflect on the life course epidemiology. It's been mentioned, when the first edition of the book came out, Guy and Yoav have just not aged at all, but I'm obviously in a different state than I was. And Guy showed this. It made me sort of think about what would be the sort of optimum graph to see for things that for big things or subjects and papers about them. And it made me reflect on epigenetic epidemiology. So this is what happened. So epigenetic epidemiology had what looked like was going to be an exponential takeoff. And I think this was a success of epigenetic epidemiology. It was that people then stopped referring to it as epigenetic epidemiology. It was just epidemiology which contained epigenetics. And we heard from Oliver about measures of smoke. But the most amazing real analysis in recent years that I've had any involvement in at all was actually having a model predicting lung cancer when reported smoking just drops out of the model. Because he used the methylation score for smoking. It just means you don't need the reports are worthless because for their own error people will report different things, etc. So so epigenetics sort of got incorporated in and would be something that epidemiology does. So it was just a sort of phase while it was being integrated into epidemiology. And and what I said in the, I was asked to write the forward, and I said in the forward, I meant it. This was a great book, and I thought it would be a great book for a general epidemiology course, because virtually anything in epidemiology, it'd be difficult now just to say what sort of area that epidemiology targets shouldn't include a life course perspective. But like saying what sort of almost like sort of so it'd be very many things will feed into any form of epidemiology. So I highly recommend this book as it would be a course book for a general epidemiology course, and a book which actually has lots of examples of actually applied issues. So many epidemiology textbooks now, don't mention population health. You know, they're methods books, and so life course epidemiology, I think, it actually grinds it down because it's got the word life in it. So it's the epidemiology that allows people's lives, which is what it has to be. So I recommend the course you get in the book. You can get a discount. You can get the editors to three of the editors to sign it. And Ezra will fax you his signature if you want it. Just thanks everyone for coming in with some drinks to celebrate its publication. Thank you. This is what you don't want to do. This is what I'm serious. This is what a dying this thing looks like. This is Mendelian randomization in the title. Purely exponential. This is per week, not per year. Per week publications of Mendelian randomization. Its title. In 28 months, every single scientific publication in the world will be on Mendelian randomization. And that's when something's dying because it's been taken over by AI and bots and paper mills. You're not like that. You don't want to look like that. Now you can have your cakes. Thank you. Thank you for coming.
There's one question. Sorry. I was not a question. I was just saying that it's really nice. Right. Perfect. Carol, for joining. I don't think there's going to be any questions. It's too much interesting. We thank you. Thank you so much for coming. Bye-bye.